All right, so example 1 says the diagram below is a trapezoidal prism. We're to calculate the area of the trapezium cross section. So this is the cross section. This shape has a uniform trapezium cross section. Now the area of a trapezium would be a half A plus B times H. Now, A and B are the area of the two parallel sides. The two parallel sides are 10 and 7.5, and H there would be the height of the trapezium. And of course, the height of the trapezium is different from the height of the prism. So from a formula, this would be A, this would be B, the two parallel sides, and this would be H, which is the height of the trapezium. And everybody should remember that height is associated with the right angle. If there's no right angle, there is no height. So this is a half 7.5 plus 10 times the height of the trapezium, which is 6. Guys, a half of 6 is 3. So this would be 17.5 times 3. What is this? Is it 52.5? Help me know, somebody. Is it 52.5?
Yes, sir.
This would be 52.5 and it's centimeters square. So that shaded shape, which is a trapezium, I just calculated the area of it, and the area of it is 52.5 centimeters square. Then now we're asked to calculate the volume. The volume is equal to A times H. A in the formula stands for the area of the uniform cross section, which we just calculate to be 52.5. So this is 52.5 times the height of the prism, and the height of the prism is here, and it is 13. So this is times 13. So 52.5 times 13, the volume of this prism is 682.5, and this is centimeters cube. All right. Now, please note, and Lasanya, I'll come back to you at the end. Now, lastly, we need the total surface area. The total surface area TSA is equal to pH plus 2A. Now, P in the formula stands for the perimeter of the uniform cross-section. The uniform cross-section here is the trapezium. H is the height of the prism. So this is the perimeter of the uniform cross-section is 6 plus 7.5 plus 7.5 plus 10. That's the perimeter of the uniform cross-section times the height of the prism, which is 13, plus 2 times the area of the cross-section, which is 52.5. This is 15 plus 10 is 25 plus 6. This is 31 times 13 plus this is 105. So the total surface area, give me a minute. The total surface area here, guys, is 508, and the unit is centimeters square. The total surface area is 508, and the unit is centimeters square. All right, so let's have a go at example 2. So example 2 is a cylinder. It says the diagram below is a cylinder of radius 10.5 centimeters and height 20 centimeters. You have to calculate to one decimal place the area of the circular cross section. Then you are asked to calculate the volume and the total surface area. All right. So very quickly, let's see what you can do in 7 minutes. All right, so for example 2, the first thing we're asked to do is to calculate the area of the circular cross section. All right, so the area of a circle, area, is equal to pi r squared. This would be 22 over 7 times 10.5 times 10.5. All right. So you're going to multiply everything at the top and then divide by 7. So it's going to be 22 times 10.5 times 10.5. So this is 2,425.5 divided by 7. And we divide by 7, we get 346.5, and this is centimeters square. So that is the area of the circle. That's it. That's what we just calculated, the area of the circle. Next, we're asked to calculate the volume. Now, the volume of the cylinder, volume V, is equal to A times H. The area of the cross section we just calculated is 346.5 times the height of the prism, which was what? Was it 20? The height of the prism is 20.
Yes, sir.
All right, so let's erase this 10 and put 20. So we then multiply this by 20. And we get that the volume is 6,930, and this is centimeters cube. Next, we ask for the total surface area. Now, the total surface area, TSA, is equal to PH plus 2A. PH gives me the area of the curved surface in the middle, and 2A would be the area of the top plus the area of the bottom. So P is 2 pi R times H plus 2 times A, which was 346.5. So this is 2 times 22 over 7 times 10.5 times the height of the prism, which is 20, plus 2 times 346.5. So let's calculate. Over to the left, pH is 2 times 22 times 10.5 times 20 divide by 7. So the area of the curved surface, which is the side, is 1,320 plus 2 times 346.5. This is 693. And we add them together, we end up with 2,013, and this is centimeters square. All right, so let's move on to example 3. In example 3, we're told that the diagram below is an open water container in the form of a cuboid. Now, guys, the open there simply means that it's open and it's a container. What it is saying is that it doesn't have a top. So this container has a total of 5 surfaces. There are the 4 sides and there's the bottom. There is no top. It is an open container, meaning that there is no top. We have the length of the cuboid is 1 meter. The width is 30 centimeters and the height of the cuboid is 40 centimeters. Now, obviously, I can't work with 2 different units. So my 1 meter will be converted to 100 centimeters. I cannot work with 2 separate units. It must be only 1 unit. You can't get volume unless you're multiplying the 3 lengths, and the 3 lengths must be of the same unit. We're asked to in centimeters cube, so the examiner is telling you which unit to go to. We're asked to calculate the capacity of the container. Now, capacity is the amount of space in the container. And space is just a simple another word for volume. The amount of space is called volume. So when I ask you to calculate the capacity of the container, what I'm asking you to calculate is the volume. So the capacity is the volume, which is equal to A times H. For the cuboid, so V is equal to, for the cuboid, the cross section is a rectangle. So it's length times width times the height for the volume. The length is 100 centimeters times the width, which is 30 centimeters, times the height, which is 40 centimeters. Guys, the volume or the capacity of this cuboid container is 120,000 centimeters cube. That's the capacity. Next, we're asked to calculate the depth of water in the container when it contained 75 liters of water. All right, so somebody poured some water in the container. They poured some water in the container. All right. No, the container is not full, and I know this because, well, I know it's not full, and I'll show you why in a second. All right, this could be done a little bit better, and I'm such a perfectionist. I am really. All right, this is better. All right, so this is the height of the water in the container, or you could say it's the depth of the container. So let's call it the height of the water. All right. And that is what we're being asked to find. We're told that this container has 75 liters of water. The container has 75 liters of water, and we are being asked to calculate the height of the water, the height or depth of the water in the container. Guys, a liquid takes the shape of its container. A liquid takes the shape of its container. So since the container is a cuboid, the water in the container is also a cuboid. Kezia, your hand is raised.
Yes, sir. I was asking why I use 40 centimeter for the height.
Why I use 40 centimeter for the height? What did you want to use for the height? Because I see 40 over to the left. I don't understand the question. Height is sort of like the thing is standing up. So the height is 40.
Okay.
Yeah, man. You could have calculated the volume if you use the numbers differently. Because you're just multiplying three numbers. Any order you multiply them in, it still work out to be 120,000. However, assuming that it's a container that's standing up, the height is 40. All right. So a liquid, guys, takes the shape of its container. Let me ask you a question. Now, the shape of the container is a cuboid, so the liquid is also a cuboid. Remember, the liquid is a cuboid because the liquid takes the shape of its container. Guys, what is the length of the container? Anybody? Help me know. What is the length of the container?
Meter.
The length of the container is 100. What is the width of the container?
30
centimeters.
30, very good. Let me ask you this. The water in the liquid is also a cuboid. So what is the length of the water? And
100 centimeters.
good. What is the width of the water?
30 centimeters.
Very good. What is the height of the container?
40 centimeters.
40 centimeters.
Good. But what we don't know is the height of the liquid. This is how we're going to find it. We're going to use the fact that the volume of water is equal to 75 liters, which is equal to 75,000 centimeters cube. Because remember, 1 liter is 1,000 centimeters cube. So 75 liters is 75,000 centimeters cube. And that is how I knew the container was not filled, because the capacity of the container is 120, and we have only poured 75,000 centimeters cube of water in it. Guys, here's what we know. Still looking at the water, the volume, which is what? Length multiplied by width multiplied by height, is equal to 75,000. Stay with me. Remember, the liquid takes the shape of the container. The shape of the container is a cuboid, so the liquid is also a cuboid. So it means that the liquid, which is the water, has length, it has width, and it has height. Guys, the length of the water is 100. The width of the water is 30. What we don't know is the height of the water, but we know when you multiply all three together, you're going to get what? 75,000. This is 3,000 H is equal to 75,000. If I divide both sides by 3,000, H would be equal to 25 centimeters. The height of the liquid in the container is 25 centimeters. Guys, the last thing we're asked to do is to calculate the total surface area of the container. The total surface area of the container. All right, guys, total surface area is equal to pH in this case plus A. Can anybody tell me why only one A? Anybody?
Sure, because you only find the area once.
No. The formula is pH plus 2A. The formula is pH plus 2A. But here I'm calculating and I'm just using pH plus A. Why only A and not 2A?
Sure, because it's one surface area.
All right. I need it clearer than that. Anybody else? All right.
So one of the container is open.
Because the container is open, it has a bottom, it doesn't have a top. And that is why we only have one A. All right, let's go back to the container. Well, we don't have to. The perimeter is 100 plus 100 plus 30 plus 30. That's the perimeter of the rectangular cross section times the height of the container, which is 40, plus the area of the base, which is 100 times 30. 100 times 30 is the area of the base. There is no top. P is 100 plus 100 plus 30. That's the perimeter of the base times the height, which is 40. So this is 260 times 40. Plus 3,000. So 260 times 40 plus 3,000. The total surface area is 13,400 centimeters square. That's the total surface area of this open container is 13,400 centimeters square. All right, so example 4 says, the diagram to the left indicates the internal dimensions of a party drink container. So the dimensions that we're seeing here, it's actually indicating the internal dimensions of this container. The first thing we're asked to do is to calculate to one decimal place the area of the circular cross section. So this is the circular cross section. We want the area of it. So area of a circle is equal to pi r squared. Pi is 22/7. The radius is 21 times 21. All right. Now the 42 there is the diameter. And the radius is a half of the diameter. So the radius is 21. 7 into 21 goes 3 times. So this is 22 times 3 times 21. And the area of the circular cross section A is equal to 1,386. And this is centimeters square. Next, we're asked for the capacity of the container. Capacity is largely another way of saying volume. What is the space in the container? Or how much space is available in the container? So the capacity of or volume of the solid shape of the uniform cross section is A times H. The area of the cross section, that's what A represents, is 1,386 times the height of the container, which is 60. So the capacity of the container is 1,386 times 60. The capacity of the container is 83,160 centimeters cube. All right, next we're asked to find the total surface area, given that the container is a closed container. So there's a top, there's a bottom. This is a closed container. So the total surface area TSA is PH plus 2A. The P is the permit of the cross section, which is a circle. So it's 2 pi RH plus 2 pi R squared. So this is 2 times 22 over 7 times the radius, which is 21, times the height of the prism, which is 60, plus 2 times 1,386. All right, which should be the area of the top and the area of the bottom combined. This goes into this 3 times. So this becomes 2 times 22 times 3 times 60. This is 7,920. That's pH, which gives you the area of the curved surface of the cylinder, plus 2 times 1,386. This is 2,772. And when you add them together, you end up with 10,692, and this is centimeters squared. So that is the total surface area of the internal of the container. Now, the last thing we're asked to do is we're asked to calculate the depth of liquid in the container when the remaining amount of drink in the container is 45 liters. All right, so 45 liters is, of course, 45,000 centimeters cubed. When the capacity of the container is 83,000, 45,000 was poured in. So the container is not full, and this would be the height of the liquid in the container. Remember, a liquid takes the shape of its container. So the volume of the liquid, so this is the volume of liquid, is equal to A times H, and this is equal to 45,000 centimeters cubed. So it's 45 liters, which is 45,000 centimeters cubed. Now, remember, the liquid takes the shape of its container. So if the area of the cross section of the container is 1,386, the area of the cross section of the liquid within the container is also 1,386 times the height, and this is equal to 45,000. If I divide both sides by 1,386, I'm going to end up with the height of remaining liquid in the container being calculator giving me problems. So I have 45,000 divided by 1,386. The answer here is 32.5 centimeters. So when the container, which is 60 centimeters high, when 45 liters of liquid remains in the container, the height of the container will be 32.5 centimeters. All right, so example 5 says the diagram below is the cross section of a block of cheese from which a slice was removed. So let me see if I can give an appreciation of this. It's like there was a block of cheese, and I know like Jamaican, a block of cheese is in the shape of a cylinder. And somebody cut out a slice out of this block of cheese. Somebody cut out a slice. All right. And so it's something like that. So it's a block of cheese and somebody cut out a slice of it. But what you are seeing is the cross section of this block of cheese. All right, after the slice was removed. So it says the cross section is a sector of 7 centimeters with center O. We are to calculate one decimal place the area of the cross section. Now, first of all, the sector angle. Of the remaining block of cheese is 360 minus 72 degrees. So this is what, 288? I think it's 288. 288 degrees. So the area of the sector, this is the piece that remains after the slice was removed, is theta over 360 times pi r square. This is 288 over 360 times 22 over 7 times 7 times 7. All right, so whatever into this goes, 72 into this goes 4 times, 72 into this goes 5, 72 into this goes 72 into this goes 5. U cancels U. So we have 4 times 22 times 7 divide by 5. So the area will be get into my calculator. Is it 123.2? Can anybody confirm that that is it? 123.2? That's right.
Yes, sir.
123.2. So this is 123.2, and this is centimeters square. All right, so in a sense, this is what the thing would look like. The block of cheese, this is what it looks like. Now we're to calculate the volume of the cheese, given that the remaining, given that the volume of cheese that remain if the height of the block of cheese is 10 centimeters. Now, this the block of cheese that remains is a solid shape with a uniform cross-section. So the volume would be equal to A times H. A we just calculated to be 123.2 a second ago.
Yes, sir.
0.2 times 10. So the volume is 1,232, and this is centimeters cube. Next, we are told that the mass, we're asked to calculate the mass of the remaining cheese, given that the density of cheese is 0.12 grams per centimeters cube. Density is equal to mass over volume. So mass, which is what we want to find, over volume is equal to density. And we want to find mass. So let's put in what we know. Mass we don't know. The volume is 1,232. And this is equal to the density, which is 0.12. Guys, if I have one fraction is equal to one fraction, and I want to get rid of the fractions, what would I do?
Cross multiply.
So 1 times the mass, this is the mass, is equal to 1,232 times 0.12. So the mass of the block of cheese is 1,232 times 0.12. This is 147.84 grams. Notice the density is grams per centimeters cube. So if you want to find the mass is going to be in grams.